Hello students, our question is a horizontal string fixed at a two end is vibrating in its fifth harmonic according to the equation, and we are given with the equation here. Assuming p is equal to, this is pi and it is 3.14, the correct statements are, we have to find which of the following statements are correct. So we start by drawing the wave, and we know that it's oscillating in its fifth harmonic, so we draw it like this. And in the other direction it will be like this. Okay, it's not an accurate diagram, but still we can manage with it. Okay, so these are two ends, and there will be node at the two ends, so this will be the length of string. Let me draw it like this. Okay, so this will be our L, and we know that the distance between two nodes is nothing but lambda by 2. So this distance will be our lambda by 2. So how many nodes are there? 1, 2, 3, 4, 5. So the total distance will be 5 lambda by 2, and it will be equal to length of string. Okay. So from here we can easily calculate the length of string, and we can easily check our second option. But we have to find lambda, and we are given with the equation. So from equation we can find lambda, as we know that it is our k, and k is nothing but 2 pi by lambda. So our lambda will be simply 2 pi by k, and k is here in meters and it is 62.8. So we write the value of k, it will be 2 pi by 62.8. So if we put the lambda in the equation, we can easily calculate L. So our L will be 5 by 2 times of into 2 pi upon 62.8. We put the value of pi, it will be 3.14. 2 will get cancelled out. So our L will be, after simplification, it will be 0.25 meters. So we can see that our second option is correct. So it is our answer for second option. So our correct statement will be second one. And if we talk about number of nodes, so we can count it from the diagram. This is our one node, this is our second node, this is third, this is fourth, and our fifth and sixth nodes. So we can easily count the number of nodes, and the number of nodes is 6. So we write number of nodes is 6. So it's not 5. We can clearly see it. So our first option is incorrect. So we put it like this. Now if we check our third option, so our third option says the maximum displacement of the midpoint of string from its equilibrium position is 0.01 meters. So our midpoint of string will be what? It will be L by 2, which is this one. Okay, so these are nodes like this we are putting here. So between, in the midpoint of two nodes, it must be a antinode. So at antinode, amplitude will be maximum. We write at antinodes, A will be A max. That is what? In this case, our equation has maximum amplitude what? 0.01. So A max will be 0.01 meters at the midpoint of string, which is true. So our third option will also be true. If we talk about our fourth option, so our fourth option is about what? Fundamental frequency. So we write D part, F is what? Our fundamental frequency, and it will be velocity upon 2L. Okay, so our velocity will be simply omega by k. We know both the values. We know the value of omega from equation and also the value of k. So we put it here. Our omega will be 628 and our k will be 62.8 meters. So our velocity will be simply 10 meter per second. And if we put this in our formula, so our F will be 10 upon 2 into length, which is 0.25. So if we simplify it, it will be 0.5, which is equal to our how much? It will be 0.5, so it will be 100 by 5, which is 20 hertz. So our fundamental frequency will be 20 hertz. So we write it fundamental frequency. But in the option, the value of fundamental frequency is given 100, so it is false. So this is our question and we have completed it. Thank you.
Hello everyone, let us start with our question. In this question, what is given? If the xy coordinate of the corners of a plate are given as to be 0, 0, L, L, 0, L, and there would be 4 point L, 0. Now the edges are clamped and transverse wave are set up. Now if u x, y denotes the displacement of the plate at points x, y at some instant, what could be the possible expression for u? Okay, so we need to check the options. Now what is the situation? Situation is like this. So these are the corners, okay, of the square. Let's say that this is our P, this is our Q, this is our R, and this is our S. So the coordinates would be 0, 0 here, it would be 0, L, and here it would be L, L, and here it would be uh, 0, L, sorry, here it would be L, 0. Here it would be L, 0 because it is lying on an x-axis. Now if we see if we see all the lines, so what are the equations of line or till where x and y would vary? For SP we can say that our y would be equals to 0 and x would be varying from 0 to L. Similarly, this is for SP. Then for PQ, this line, our x would be fixed at L and y would be varying from 0 to L. Similarly, if we check for this line, RQ or QR, for QR, y would be fixed at L and our x would be varying from 0 to L. Similarly, the last of our line, this RS, for RS we can see that x would be equals to 0 and y would be varying from 0 to L. Now we need to check, this is the condition which is given that the edges are clamped. Now if the edges are clamped, we can see that if edges are clamped, okay, then we can see that the displacement at the clamped portion or at the edges, this would be equals to 0. This would be the displacement at the clamp. Now what we do, we just check for each and every expression, that the edges, that SP, PQ, QR and RS, whether the displacement is turning out to be 0 or not. So we write our first expression where u is given as to be a, this cos pi x over 2L, then cos pi y over 2L. Now this is our A option. Okay. Now let's check for our HSP. Now for SP, our y would be equals to 0. Now if you put y to be 0 into this expression, then our u would turn out to be a cos pi x over 2L. Now this would not be 0. Why? Because this factor would not be 0 because our L is varying from 0 to L. If we put our value of L from 0 to L, so it would not be 0 for each value of L. So we say that this is not equal to 0 for the x varying from 0 to L. Okay. So we can say that this cannot be our option. So similarly, we check our B option. If we check our B option, okay, in the B option, it is given that our U is given as to be, which I just checked U. So it is a sine pi x by L sine pi y by L. So it is given as to be a sine pi x over L and then sine pi y over L. Okay. Now if we check For SP, if we check for SP, we know that y would be equals to 0. So if you put y as 0, so this term would be sine 0, and sine 0 is 0. So we can say that our u would be equals to 0. Now similarly, if we check for PQ, now for the surface PQ, our x would be equals to L. Now if you put x equal to L into this expression, it would turn out to be sine pi, and sine pi is 0, then u would be 0. Now if we check for our QR, we can say that y would be equals to L. Now if you put y equal to L, it would be sine pi, and sine pi would be 0. And similarly, at the last we check our RS. Now for RS, x would be equals to 0. If we put x equal to 0, again u would be 0. That means at each and every edges, this is satisfying our equation, then B would be one of the correct option. Similarly, we check for this C option. So for the C option, now if we check our C option, now there is just a difference of 2 here in the C option. Okay, rest of the thing is same. So it would be just same type of expression. We just write the expression here, and it would be just same. It would be a sine pi x over L, and then it is sine 2 pi y over L. Now if you put similarly, if you put y to be 0 for SP, then this function would be 0. That means u would be 0, exactly same. Now for x equal to L, if you put x equal to L into this expression, it would be sine pi, which is equals to 0. Then our u again would be 0. Similarly for QR, if you put y equal to L into this expression, then it would be sine 2 pi, and sine 2 pi would again be 0. Similarly for RS, x would be equal to 0. If you put x to be 0, then u would be 0. That means C would another be the correct option, because for the C, we are getting u would be equals to 0 for edges. That means C is also a correct option. Now if we check for our D option, now D option is just similar to our A option. Just that here the 2 is coming here. Now if we just check let us just check in the D option. We just write our D option where u is given as to be A cos, then it is A cos, let's check what is A cos 2 pi x over L. So 2 pi x over L, and then we are having sine 2 pi y over L. Let's check whether it is 2 pi or pi, just pi. It is 2 pi x over L. Now if we check for this option, if we put our check for the surface PQ, if we check it for the surface PQ, now we know for PQ, x would be equals to L. Now if you put x equal to L, what expression would look like to be? It would be u equals to, now this L and L would be gone, cos 2 pi. So cos 2 pi would be basically having a value of 1. Now, so u would then turn out to be a sine 2 pi y over L. Now this value would again not be 0. So u would not be 0 for our surface PQ. Okay, that means we can say that our D would be incorrect option. So the correct option would be our B option and the C option. So hope you have understood the solution. Thank you.
Hello friends, question is given here. Velocity of sound in air is 320 meter per second. A pipe closed at one end has length 1 meter given. Okay, so neglecting the cross section, the air column in the pipe can resonate for the sound frequency. Okay, so here 4 options are given: 80 Hz, 240 Hz, 320 Hz and 400 Hz. Okay, so we know fundamental frequency F1 is equal to velocity of sound, okay, upon 4 into L. Okay, so here velocity of sound is given how much? 320 meter per second upon 4 into L value is how much? 1 meter. Okay, so 4 into 1, so that is equal to how much? 80 Hertz. This is the fundamental frequency. Okay, so we know in one end closed pipe, higher order harmonic are odd integral multiple of fundamental frequency. Okay, so we can write Fn is equal to 2n minus 1 odd integral of fundamental frequencies. Here how much? F1. Okay, so where C where n will be n is equal to 1, 2, 3, 4. Okay, so now see, so higher frequencies are when n is equal to 1, so f1 will be how much? 2 into 1 minus 1 into f1 value is how much? 80 Hz. So this will be how much? 2 minus 1, that is 1 into 80, that is equal to 80 Hz. Okay, and when we put f is equal to n is equal to 2, so f2 will be how much? 2 into 2, 4, 4 minus 1, 3, 3 into 80, that is equal to 240 Hz. Okay, and here f3 will be how much? f3 is equal to 3 into 2, 6 minus 5, 6 minus 1, that is equal to 5 into 80, that is equal to 400 Hz. Okay, and f4 here is equal to how much? So here n is equal to 4, so this will be 8 minus 1, 7 into 80, that is equal to how much? 560 Hz. Okay, so see here, 80 has 240, 80, 240 and 400. So option A, option D and 240, that is option B will be the correct option. Correct option will be A, B and D. Okay, A, B and D. Thank you.
देखिए इस क्वेश्चन में क्या है, एक साइलेंडर रेजोनेंस ट्यूब है जो कि ओपन है दोनों तरफ से और उसकी फंडामेंटल फ्रीक्वेंसी है एफ एयर में। अगर हम हाफ इस लेंथ को वर्टिकली डिप कर दे वाटर में तो फंडामेंटल फ्रीक्वेंसी एयर कॉलम की क्या होगी ये हमें बताना है। तो देखिए सपोज करते हैं ऐसा कोई सिलेंड्रिकल ट्यूब्स हैं, ठीक है। देखिए इस क्वेश्चन में क्या है, ये हमारा एयर कॉलम में क्या होगा, ऐसा कुछ होगा। ये डिस्टेंस बिटवीन टू नोड्स या और टू एंटी नोड्स क्या होता है, लैम्डा बाय 2 होता है। तो यहाँ पे हमें अगर गिवन है कि इस पूरे सिलेंडर ट्यूब की लेंथ L है और हम हाफ में सेकंड केस में क्या कर रहे हैं, हम वाटर में डिप कर रहे हैं, तो L/2 ऊपर बचेगी। अब हमें पता है कि डिस्टेंस बिटवीन टू नोड्स और एंटी नोड्स क्या होता है, ये होता है लैम्डा बाय 2, ठीक है। तो मैं क्या लिख सकती हूँ यहाँ से मैं लिख सकती हूँ कि दो नोड्स या दो एंटी नोड्स के बीच में डिस्टेंस है L, तो लैम्डा बाय 2 क्या है, वो L है। तो मेरा लैम्डा क्या आ गया, 2L आ गया फर्स्ट केस का। अब फ्रीक्वेंसी F क्या होती है, ये होती है C बाय लैम्डा, तो ये हो जाएगा C अपॉन 2L। अब सेकंड केस में देखिए डिस्टेंस बिटवीन अ नोड एंड एन एंटी नोड कितना होता है, डिस्टेंस बिटवीन नोड एंड एंटी नोड होता है लैम्डा बाय 4। इस केस में अगर मैं इसकी वेवलेंथ लैम्डा डैश बोलूँ तो लैम्डा डैश बाय 4 हो गया। तो ये है हमारा एक नोड और एक एंटी नोड के बीच में डिस्टेंस, वो है L/2। तो मैं यहाँ से क्या लिख सकती हूँ, लैम्डा डैश बाय 4 कितना है, L/2 है। यहाँ से लैम्डा डैश कितना आ गया, लैम्डा डैश आ गया 2L, ठीक है। और फ्रीक्वेंसी F क्या होगी, F डैश होगी मेरी C अपॉन लैम्डा डैश, ये हो गया C अपॉन 2L, यानी ये F के इक्वल आ गई। हमसे पूछा क्या था, एयर कॉलम की अब फ्रीक्वेंसी क्या होगी, तो न्यू फ्रीक्वेंसी भी ओरिजिनल फ्रीक्वेंसी F के इक्वल ही होगी। तो हमारा ये आंसर आ गया, ठीक है।
Hello students, today our question is, in a sonometer wire the tension is maintained by suspending a 50.7 kg mass from the free end of the wire. The suspended mass has a volume 0.0075 meter cube and the fundamental frequency of wire is 260 Hz. If the suspended mass is completely submerged in the water, the fundamental frequency will become, so we have to take acceleration due to gravity is 10 centimeter here. So the solution of this question is, firstly we can draw the diagram for it to understand it better. So this is our is maintained in the this. So we can, this is our wire. So air is something like this. So in this direction we have force on FB, and in this direction we have M, mass into gravity. So tension 1, this is the tension 2, and this is the tension 1 here. So tension 1 in the wire is mg, mass into gravity. We have the M is given to us 50.7 kg here, and G is 10. So from this we get 50.7 into 10 is equals to 507 kg meter per second square here. And we have the tension 2 is T1 minus, and this is FB. So we can find here FB is equals to rho of water, that is density of water, and this is volume, and this is G here. So from this we get FB is, we know that density of water is 1000, and we have the volume is given to us 0.0075 here, and G is 10, as we have the volume is 0.0075 and density of water is 1000, and we have put the G here. So from this we get FB is equals to 75 Newton. So this is the force on this, and from this we can write here. Now we know that velocity is V is directly proportional to T, that is, and frequency 1, if we take frequency 1 divided by frequency 2, so this must be equals to tension 1 divided by tension 2. So from this frequency 1 is equals to tension 1 is 507, and tension 2 is given to us. So we have to calculate the tension 2 here. So the tension 2 is equals to T1, that is 507, and this is minus FB, that is 75 here. So this will equals to 432 Newton here. So this is our tension 2. So we can highlight here. This is tension 1 and this is tension 2 here. This is tension 2 here. So if we put here 432, and from this we get V2. Frequency of V2 is V1, and this is in multiplication with, this is in multiplication with T2, that is 432, and this is divided by 507, as it will goes in the multiplication, so the it will goes here, denominator will be in numerator, and on solving this we have the V1 is 260 given to us, and this is in multiplication with 432, and this is divided by 507. So from this we get frequency of second is equals to, this is 240 hertz here. So this is our answer for frequency 2, and we have written, we have taken V1 is equals to, it is given to us, given here. So this is our answer. Thank you.